We are live. Hello, folks. My name is Joe Fuller. I'm a solution architect here at Buoyant. You will recognize if you've seen any Service Mesh Academy episodes in the past that I am not my esteemed, better-looking colleague, Flynn. I'm just standing in as host today. With me, I have Ivan Porter. Ivan, do you want to just introduce yourself quickly to the folks?
Sure. Hi, everybody. My name is Ivan Porter. I'm a customer success engineer here at Buoyant. And today we're going to talk about ingresses.
Cool. Just a very, very quick piece of housekeeping before we get started. And there is a poll that some of you have already voted in. It'd be great if I'll keep it on just for a couple more minutes. Are you currently running Ingress NGINX in production? So everyone go and vote there, and I'll remove it, and then we'll have another poll at the end, or a bit further into the episode. The second thing is there's a chat function. I'll be keeping an eye on that chat function. So any questions, please post them, and I can sort of interrupt Ivan during his demo and slide deck. And then if there's any questions that require a little bit more of a thread, a back and two, then we've also got the workshops channel in the Linkerd Slack as well. Okay. Well, Ivan, I'll hand it to you.
Perfect. So let me change the slide. Perfect. So yeah, let's talk about Ingress NGINX, which I want to highlight that NGINX is different from Ingress NGINX. There are two different projects. One is open source, which we're going to see later. You're still okay. You're still visible. You need to mute yourself, otherwise you're going to be visible forever.
Oh, okay.
No worries. So yes, so there are two different projects. But let's start from Ingress NGINX. So Ingress NGINX is the open source version of the Ingress controller. You can see here the project was hosted on GitHub and has been archived recently. Archive means that was maintained up to a specific date. Now that is archived, cannot be changed. And that's actually what creates some issues, because the code cannot be changed. There might be new CVEs, new bug fix that need to be implemented in the code, but because the code is archived, is not maintained anymore, it cannot be changed. So we're going to stay there. And that's a problem it's not a problem for test demo environments, but if you have something in production, that might be a problem. You need to be compliant to specific compliant rules, let's say. And it might be required no CVs, no ICVs, no critical. And because you cannot change the source code, that's a problem. You might have to create a fork of the Ingress controller and maintain it by yourself, but that will require a lot of overhead on your team, because you will actually find yourself maintaining an Ingress controller, which is no joke. So just to give you an idea of why was a big problem, is a lot of organizations were relying on Ingress NGINX as an entry point for their clusters. Like, for example, you can see on the right, Traefik Lab, they're saying that a lot of half the organization that using Kubernetes were still using Ingress NGINX in their production cluster, even after it has been retired. And there are several references, even in the Kubernetes official blog, mentioning the same issues. Like, for example, they mentioned Datadog, but 50% were still relying on Ingress NGINX. So we can see that even though it's been retired, a lot of organizations are still relying on it, because switching might not be that easy, might require planning. So it's good to know what options do we have. But before we dive into Linkerd and how Ingress controllers behave with a proxy in front, let's talk about Ingress controllers. So we have a cluster. Let's start from the left. There you have users outside the cluster. We send a request to a specific endpoint. That endpoint is resolved to a specific IP, which is our Ingress controller balancer. That is routed to the Ingress controller that apply the routing rules, because it is actually watching, we're going to see later, watching endpoints and services in the Kubernetes API. So when there is a request arriving to the Ingress controller, it knows about these endpoints and services, and then applies some load balancing algorithm to send the request by default directly to the pod IP. So that's actually the flow by default with the Ingress controller. Now, we can see in the logs, in this case, these logs are related to NGINX. If increase the verbosity of Ingress of NGINX, you can see actually, let me actually remove my face, which is covering the logs. You can see here that, first of all, these are the watches. We can see in the watches that is constantly establishing these watches against the endpoints and services in the Kubernetes API. And then we can see here that when it's actually sending a request, is automatically resolving against the pod IP, not the service. And that's actually the problem. But we're going to see later why is a problem. So if we want the Ingress controller to resolve, to load balance against the service and not directly against the pod IP, there are several annotations which vary depending on the Ingress controller. So in case of NGINX, there is the NGINX Ingress Kubernetes.io service upstream true, which basically is telling the Ingress controller when there is a request coming in, do not resolve against the pod IP, but send the request to the service IP, which then is going to be like load balance against the pod IP by something else, which depending on what we have in the Ingress controller. So if you look at the logs, we can see now that the target, the server, basically the server's target by the Ingress controller is not the pod IP anymore, but is the service IP. How does this work with Linkerd? So we know that Linkerd is a proxy that sits in front of the application pod. The application pod is nothing different by an Ingress controller. So it could be your application, could be an Ingress controller. If when you inject the Linkerd proxy, will deploy the proxy in front of the Ingress controller, the same way as in front of the application. So when there is a request coming in, we reach the proxy first, which will then forward loop back against the Ingress application or the Ingress controller, which will perform its load balance, and then we'll send the request back to the Linkerd proxy that will do some stuff. Now, the proxy gets the endpoint, the target endpoint, based on the Linkerd destination. But now the kind of, let's say that you get the policies from the Linkerd destination, then we'll apply these policies against the target endpoint from the application, which in this case is the Ingress controller. But what I want to highlight is the fact that Ingress controller and the Linkerd destination are watching the same resources. They're both watching the endpoints and the services, so we are performing the same thing. Then the proxy will subscribe to the get and the get profile to get the policies and get the service discovery and everything else. But there is a lot of work happening at the level of the Ingress controller and the destination. Now, I have a quick question for you. And I'm going to give you 5 seconds to think about it. In this case, we don't have the annotation on the Ingress. We are using a default Ingress control, NGINX Ingress controller. What do you think is going to resolve in this case? If there is a request targeting a specific service, what do you think, without the annotation, what do you think is going to be the IP that the Ingress controller will use for as a bound, let's say? I'm going to give you 5 seconds to think about it. Okay, the P is going to be the pod IP. As I mentioned before, without the annotation, we'll just, or specific annotations, or specific services, we'll just simply target directly the pod IP. So the Linkerd proxy will see an IP, just one IP, so it won't perform any load balancing. So we'll send a request to the IP that is received by the Ingress controller. Now, let's assume that we added the annotation to the Ingress in this case for NGINX. What do you think will be the IP that the proxy will receive from the Ingress controller? I will still give you 5 seconds to think about that. So in this case, it's going to be the service IP. And because Linkerd is also performing load balancing against the basically policies, but also against the service through service discovery, we'll receive the service IP, and then we'll apply a specific load balance based, in this case, N1, which is the load balancing algorithm used by Linkerd based on the latency. So in this case, the load balancing of the bound of the proxy will be basically honored by the proxy, not by the Ingress controller, because we use the service. Now, you might say, oh yeah, but what's a big deal? Like if at the end they're still routing to the same pod, so why do you need to even bother about adding this annotation? And the problem is if you're doing traffic split. If you have like HTTP routes, in this case, the IEP that the Ingress controller is sending to the proxy might not match the desired routing. For example, in this case, we don't have the annotation in the Ingress. So the Ingress controller will choose or load balance against one of these two pods. So even though we have a primary and canary, the primary is on top and the canary at the bottom, and we have a HTTP route at the bottom left, which is setting all the requests, 100% of the requests to go to the canary. Because the Ingress controller is choosing the IP during the load balancing and is not, in this case, taking into account the HTTP route, the outbound of the proxy will be will still be the primary. It's not going to be the canary, even though we have the HTTP route, and that's a problem. This is why we need to when we use, for example, NGINX, we need to add this specific annotation to the Ingress in order to tell the Ingress controller, do not choose the pod IP for me, just select the service and something else will do the rest. And that we'll see this requirement applying to a lot of different Ingress controllers, which we're going to see in a minute. So there are many different Ingress controllers out there. There is NGINX, there is Gateway, Envoy Gateway, Contour, Traefik, Kong, and many more. These are just a few that we did some testing for this SMA. NGINX, we talked about that earlier. We had annotation in the Ingress, and that will tell the load balance, the Ingress controller, to just choose the service.
Ivan, quick question. So while we're talking about alternatives, are there alternatives that you're seeing most often in the field? I mean, you talk to customers every day. Are you seeing there being a sort of leader in folks moving away?
I would say that Traefik is pretty good. A lot of customers are using Traefik. Also, I would say the least one so far is Contour. On the podium, I will see Traefik and Envoy Gateway.
Cool.
So, as you can see, we have different Ingress controller. Each one of them have a different way to change the load balancing and then to return a pod IP or a service IP. So, Joe, you're not on mute.
It's fine. Yeah, I have a follow-up. And so you've seen lots of folks move to Traefik. Why do you think that is? Is it because the transition's easier? Is it an easy migration path? Some of these alternatives have got migration tools now, right? That does the conversion of some of these sort of Ingress objects to the new Gateway API objects, right?
I'll be honest. Like some clients did. I mean, this I haven't done the same, but they did some benchmark and they noticed that some Ingress controller are less resource intensive than others, and that made them choosing one rather than another ingress controller. But to be fair, it depends also what you want to achieve. Like, for example, if you want something more modern and more like aware, agent aware, you can use Gateway. Traefik is pretty good. Like they did a lot of work with Traefik, especially in the latest version, where you can enable a gateway API out of the box with a specific flag in the hand chart. So there are different options. Some are easier to configure than others, in my opinion.
Okay, yeah, the resource consumption is a big thing, right? I mean, Linkerd is well known for being very low and performant when it comes to resource consumption, and so like those things would go hand in hand, right?
Yes, absolutely. Like I noticed that there were in the past there were several issues where people configure limits on the ingress controller, then they had spikes in traffic, and then that went out when killed, and that was a problem because a single point of entry for your cluster, and if that's down, nothing enters. So if having something that is not taking away all your resources is pretty good. Also because if you're using cloud service provider, you pay for those big nodes. So
right.
Yeah. So, for example, as I mentioned, all of them have different ways to configure the ingress controller to point to the service or not. For example, Gateway is using static. This is the specific type of backend which allow you to specify a host, and then basically when you configure the ingress, I think I don't remember the check. Basically, you configure this backend, and then it will not perform basically resolution. It will just use the service. Others are much easier, like for example, Traefik and Kong. You just add annotation. They're like for example, they're very similar. You add annotation in the service. In Traefik has service native load balance, while in Kong is basically service upstream is very similar to NGINX, and basically they perform the same thing. Others, like for example, Contour require like the creation of a specific type of service, which in this case is external name, which basically result in the same thing. Basically, we return the service IP instead of the pod IP. So the question is, what if you're using a legacy ingress controller? Will that still work? The question is, no, not always. Because some of them are like, for example, Traefik recently added the particular annotation. So in previous version, you require to create middleware or other resources in order to basically use the service IP instead of the pod IP. So not always, it might be more complicated. So what do we do with these legacy ingress controllers? And the question is Linkerd ingress mode. So what is Linkerd ingress mode? Let's go back to our diagram. We still have the ingress controller, which is meshed with Linkerd. But in this case, instead of Linkerd inject enable, we use Linkerd inject ingress. What does it mean? We will see that in a second. So when you enable that Linkerd inject ingress, there are a couple of things you can see. First of all, in the environment variable, you will see this new Linkerd proxy ingress mode set to true. Then in the logs on the right side, you can see that there's going to be an additional line set to info. So you need to change the debug, the verbosity to see this line. It's going to be because info is the default verbosity level. You'll see outbound routing in ingress mode. And that's basically just telling us Linkerd is meshing ingress mode. But what does it mean in terms of traffic flow? So we have the same diagram, we have the ingress, and then we have the Linkerd proxy injected in ingress mode. What does it mean is when there is an inbound request for the proxy will route the request based not on the IP, but based on the header of the request. What does it mean? let's say that we still have the ingress. Let's use NGINX again. We have NGINX without annotation. So it will resolve the service and we'll choose a load balance against the pod IPs. So we'll turn one pod IP. Now we have the middleware where we configure the L5D. Basically, we add a header to the outbound of the ingress controller with L5D destination override. And we add this service, which is the primary. The primary on the right side, you can see here, has the weight set to 0. And everything is routed to the canary. So before we go forward, let's recap all the moving parts. Yeah, ingress controller without the service annotation. So is resolving the service and is returning a pod IP based on the load balancing algorithm. Then we add the custom request header, which is adding an additional header to the output, to the outbound of the ingress controller, in this case pointing to the primary service. And then we have the linked proxy. So when the request reaches the proxy will see the pod IP, which is, in this case, is going to be primary. So if you didn't have this custom header, we'll just simply send the request to the primary. But that's not what we want, because we want it to be routed to the canary with weight 1. Because we added this annotation and we have linked in ingress mode, linked will ignore the pod IP and will resolve against the primary. So the proxy will get the policies. We'll get the policies for this HP route. We'll see, okay, all the traffic that is targeting the parent ref, in this case the primary service, has to be routed to the canary. So it will apply the policy and send the request to the canary. And this is an example. It was pretty tricky to find this L5D override, but for example, in this case, I had to use an enter to get everything about in the node, but basically the bound of the ingress controller added this L5D destination override, and you can see here simple up v1, which is basically the same. And when you reach the proxy, it is routed to the canary because it will apply the routing policies. So this is basically a way that you can avoid, for example, mostly in legacy or ingress controller that don't allow to return the don't resolve the service. In this case, you can use the ingress controller. So you're telling the proxy, okay, resolve the service for me based on the header. So now let's go to the demo. Let me share my terminal. Share screen. And yes. Okay. And let me select this. There we go. So this is my terminal, and we could still get pods. I show all the pods that I'm running here. I have K Gateway, which is still 0 out of 1. That's interesting. Then Ingress NGINX. I have Traefik. I have Linkerd installed. I have free application. And you can still get HTTP root.
Just for people watching as well here, Ivan. This is a real Kubernetes cluster. Like, where have you deployed this? Just for a bit of context.
I'm running this cluster in my local K3D environment, and K3D list. Oops, I think it's list of K3D cluster. List, yes, in the 01 as a load balancer. So when you're gonna see me later sending requests to localhost port 8081 is because this K3D cluster is a load balancer to port 8081. So everything is sent to localhost 8081 is gonna be load balanced to the cluster. Now we have, just to recap, we kubectl get SPC, pods, and simple up. Now we have pre-deployment. and free pod and free services, and we have HTTP root, which is this one. And what is doing the HTTP root? Let's take a look to talk a little bit about that. So we have the HTTP root deployed in a simple app namespace, which is routing all the traffic pointing to the simple app v1 service on port 80 to one of these backends. In this case, we are sending everything to v2. Now, here, kubectl get ingress. We have an ingress here. kubectl get ingress. And YAML. So what do we see here? We can see the ingress, you can see the root, everything basically reaching later on port localhost 8081 is going to load balance, it's going to match this path, which is empty path, and it's going to be routed to the simple app v1. As you can see here, we don't have any annotation. Now, let's send some requests. So it's going to be curl localhost 8081. Now, something went wrong. Why is still routing to simple app v1 when earlier we specified everything to go through the canary? I'm gonna give you 5 seconds to think about that. Why is not honoring this HTTP route? And the answer is missing the annotation. We can see here in the ingress, we have the ingress, load balance everything, but this ingress doesn't have annotation, is not pointing to is not returning the service, it's just returning the pod IP. And we can see that in the logs. kubectl get pods, and if we inspect the logs of the ingress controller, which is this one, logs here, and we are gonna see here. Oh no, sorry, this is the pod. It's gonna be -c controller. Okay, we can see a lot of stuff here, but let's see. Yes, that's actually the only way to see how it's routing. So let me send another request 1 second. Oh, it's gonna be at the end. So curl simple app v1 and here. Let me just get the pods 1 second. F1 def and simple app wide. Simple. Okay, so we're gonna see something like 2021. Grep 2021. Okay, here. So we can see here that is routing directly to the pod IP. And that's what we don't want. We want to be routed to the service, so the proxy can do the load balancing. Now, let's change the ingress. Before actually we move to other ingresses, let's change the ingress. So let's go to kubectl edit ingress and simple app. kubectl. Okay, now here we need to add annotation, which was, I think was here, I don't remember. No, this one. Let me just copy here. Okay. And annotation. So service upstream. And let's write this one. And let's another request.
And this trips people up quite often, right? Like this is quite a common ask when you're sort of working with customers on sort of routing challenges. Like we often see it's quite a common issue, and it is documented.
Yes.
On our website.
Yes, we have a page in our docs that basically will guide you on the configuration of different ingress controllers, like from Traefik. Actually, Traefik has 2 different options. One with roots, ingress roots. I don't remember the exact name of the resources, and the other one is using annotations, for example, for the latest one, but changes. So let's send another request. What we expect now that is sending a request is to say simple up v2, because if you check the logs again, and in this case, not this one, here get svc, simple up, and all wide. So we expect something like this one or this one. Let's check. Actually, simple up v2, actually v1, because it's the proxy doing the routing. So if you check the logs, and we grep for this IP, we can see here at the end, there is a request which is pointing to the service on port 80. And this is the service IP. So the service IP reaches the proxy see the service, the proxy see the endpoints based on the service, apply any policy, and then route the service to, route the request to simple v2, because it's honoring the HTTP routes. So this is the first flow. Now, let's delete this ingress. Still delete ingress. Actually, let me get the ingress. Get ingress. And simple up. And let's delete this one. So we're not going to use NGINX anymore. Because actually, this entire SMA is about NGINX retiring. So why are we even talking about NGINX?
It's a good starting point. It's a good starting point. But at some point, we have to kind of move
yes.
next, right? Yeah.
Yes. Yes, we need to delete ingress. Okay, so we don't have ingress anymore. We still have NGINX, but because we don't have ingress, it's not doing anything. I can set a curl, it's just gonna be lost.
404. Yeah.
Let me even delete the Ingress NGINX. So helm and list of A, and then let's delete this one. Helm uninstall. And then, oops, install. What is missing? Okay, perfect. So we don't have NGINX anymore. We send a curl. It's just gonna be there. In this case, we get 504 not page not found, which is basically Traefik. Traefik is taking the lead now. Now we have two options with Traefik. We saw like the load balancing using the service resolution. Now let's say that we want to honor the request based on the header, because we don't want to let Traefik return, prevent the resolution of the service. We want Traefik to do his own thing. So let me still get pods, and then simple up. And let's go also get the HP root. Yes, there is a space here. We still have the same things with everything going to simple v2. Traefik resources are slightly different. So let me start deploying the annotations. 1 second. Okay. So first of all, let's deploy the middleware. So the middleware is going to be kubectl apply ref, and then we apply this middleware. What are we doing? We are just deploying a middleware, and we are telling, okay, perfect. For this middleware, simple v1, when there is something targeting this middleware, add this annotation, which is the same thing that we saw earlier in the slides. Now, we have a middleware, but that's not enough. It's still not routing anything. Now, let's add ingress route. So kubectl apply f, and then the rest. So what's happening? Now, when there is a request matching this prefix with v1, what it's doing is, okay, perfect. Let me apply, when there is a request matching this v1 prefix, I will simply send the request to the middlewares, which is simple v1. And the service that you need to match is simple v1 port 80. And then you see v3 is will apply the middleware v3. But we don't have v3 yet, so that's fine. Now, let's send a request. Let's say curl localhost 8081. Page not found v1. Now, you're still saying the same thing. It's like, why? Why it's still sending to v1 and not v2? And the question is, we're still missing something, which is actually, I think is because we are missing the middleware in v3. Yeah, apply. It's actually, oh no, actually, 1 second, clear. kubectl, get pods, and Traefik. Is mesh. Yeah, I think it's because I didn't create the other middleware. kubectl, apply. Okay, let me see again. v1 and v3. So it's honoring the v1, v3 is applying simple up v1. Let me think. The best of the live demo.
Yes. I wondered how long it would be, if at all, until the demo gods kind of got involved.
Entry points web. I think I'm missing something. 1 second.
Whilst you're just looking at that, I'm just going to post another poll, which is the question is going to be, which replacements are you leaning towards for those that either have or are thinking about moving away?
Okay, you know why it's not working? Yeah, get Traefik, get pods and Traefik, and then iPhone or YAML. And I think the problem is not Ingress mode. So as I mentioned earlier, like when it's in Ingress mode, we say actually Ingress. Let me see, we can see here. Yes, there we go. That's the problem. So even though we have Traefik, we are adding the annotation. Actually, it's nice that it's not working because we actually had the opportunity to see why. So we saw the Traefik. We added the annotation, but it was still routing the request to simple v1, even though we added the annotation. So why? Because we added the inject enable, and that's the problem. Now, if we kubectl edit, deploy, and Traefik, and then Traefik, and click, kubectl get deploy.
We have a vote for haven't decided in terms of replacements. So maybe this is an unofficial demo / advert for how simple it is to work through working with Traefik.
Yes, I need to change the injection because we are injecting Linkerd in enabled, but we need to inject with Linkerd template. Where is it? Okay, 1 second. Let me select this. Like this. Sorry.
And this is Ivan. This is I guess the reason why we publish documents, right? Documentation.
Yes.
Right? So that like when folks are deploying these gateways as Ingress controllers, they have some reference to like question if they are configuring things correctly.
Yes. The problem was it wasn't basically when you inject Linkerd is basically there are several places where you can define the Linkerd configuration, like the annotation. One is the namespace, one is the deployment, and then that's basically the pod. So when the proxy injector see the annotations, we'll see, okay, see the annotation in the namespace. But then if you define something different in the deployment will take the priority over the namespace annotation. Then if you define something more, like the pod, for example, then that will take precedence on the deployment. So there is this hierarchy in how the proxy injector works. So the reason why we weren't finding anything in the deployment of Traefik is because you applied the annotation in the namespace. Now, if you check the Traefik, the pods, click, then YAML, and we scroll up, we can see, let's start with the annotation. Yeah, linked injected ingress. And then if you scroll down in the environment variables of the proxy, we're going to see ingress somewhere. Let's see if we can find it in a few seconds. Yes, here. Link the proxy ingress mode true. Now, everything is in place, right? To work. So if you send a request, curl localhost 8081 and /v1, simple OB2. So we didn't change anything on the Traefik point of view. We just change how the proxy apply the routing rules based on something. In this case, because we have the middlewares, let me reopen the ingress route. We still get ingress route A. So because we are applying these middlewares, which perform some kind of operation of the bound, basically, and we added this annotation, the proxy will receive a request with specific annotations based on these middlewares, which can be different. We can, for example, if you send the request to v3, it's doing something else than v1. So it's not like you have to create a lot of ingress routes. You can just simply create one and then apply multiple middlewares to add these annotations. So, but this is for Traefik. Other ingress controller are the requirements. So, that being said, we saw earlier today, basically, just to wrap it up, we saw how Linkerd works, how the routing, how Linkerd define the routing rules, apply those routing rules, when it is the one honoring the HP route or not, based on something, and how can we achieve these, let's say, we perform the resolution in the ingress controller, yes or no, based on specific annotations. I think we still have some time, so yeah. I will move to the Q&A if you have any questions.
I have a question actually, Ivan. I've been thinking about through this, which is it looks fairly straightforward to sort of move away, move across. There's many alternatives. We've kind of mentioned Traefik is a popular alternative to NGINX that most folks are kind of migrating to, or many are. What's the biggest challenge that you've seen from a sort of engineering perspective in doing that migration from an operational? Like should engineers that are watching this, or anyone that's considering a move, be concerned about any, like, is there anything to really watch out for?
Well, the problem is like, it's not something that you can do from 0 to 100, because like rather than like detaching everything, I would rather like having both of them and then like starting defining rules so that your ingress controllers is actually doing work. Now, NGINX, as I mentioned, is being retired. Yes. Is gonna stop working? No. So if you decide to move away, something that you should start considering, you should plan the migration, which might require some steps. Maybe you can start deploying the CRD and creating the resources, and then deploy the other ingress controller, and then cut off the NGINX. Cool. But there is definitely some planning that need to happen.
Yeah, as there would be in any migration, right? A couple of questions from Jude in the chat. The first one is, I want to ask is, how do you use this in Azure, right? So I'm presuming, Jude, you're referring to like an AKS cluster there, Azure Kubernetes cluster. Do you want to take that one, Ivan?
Sure. But well, NGINX, when you have Azure, I don't remember that. When you have Azure, does it come with NGINX? Not sure. I think you need to install NGINX, right?
Yeah, I mean, from my experience, I don't think there are any kind of native plugins or native ClickOpsy ways of deploying NGINX. I think some of Microsoft's own maintained, I think the application gateway is an add-on, but I don't think NGINX is. And so so I think what are you getting to the point of, okay, NGINX will just deploy the same as any other? And also, like, is Traefik, again, in the same question, like, is there anything about Azure in particular that teams will need to consider when doing this work?
Well, to be fair, like Azure is AKS and EKS are nothing more than managed Kubernetes. So, which means that you don't need to worry about VM, spin up VM, or doing all the networking that you should do with a vanilla Kubernetes. It's just someone else doing that for you and making sure that they're up and running when you need them. But still, you still need to, if you're not using cloud resources, like for example, AWS, Application Gateway, or other services, managed services from AWS or Azure, you will need to install these Ingress controllers. And then, because you install them, you can apply basically the same configuration, the same values that you will do, for example, if in my, as I've done today, with as I did today with the Traefik. You need to ham install and blah, blah, blah.
Right. Yeah, and we should actually stress as well, if you've not already mentioned this, Ivan, you may have, and I may have missed it, but this is the community version of NGINX.
Yes,
retired.
Absolutely.
There is a commercial version which is still available. F5 provide, that's a whole different entity in terms of like security patches and maintainability there. So just wanted to make that distinction.
Yes.
In terms of white papers, I mean, I know that generally following these service mesh academies, there's a blog written. But are there any specific white papers that you've seen out there, Ivan, about moving away? Do any of the alternatives, such as maybe Traefik, do they offer any white papers in terms of migrating?
I'll be honest, like when the NGINX Ingress controller officially said that they were going to retire, all these other Ingress controller jump on it like bees on honey. So I start creating a lot of documents saying, how to move away from NGINX. NGINX is deprecated. You need to do something by the way. This is the best option. So you're going to find a lot of documentations about these other Ingress controllers, how to move away from NGINX on their own service. Okay,
cool. And so I think we've got a few minutes left. I just wanted to quickly touch on the poll that I posted, which the question is, which replacement are you leaning towards for anyone that hasn't moved and still needs to, right? And it looks like the overwhelming answer is haven't decided. So I'm not sure if that is because of the demo gods interfering with your demo and not selling Traefik as a replacement. But yeah, it looks like folks are still not sure what to do, where to go to. But they need to go soon, right, Ivan? Because again, the amount of CVs that these AI models are now sort of finding, like the number of security patches that are going to.
If you have some time, you can actually see. Let me see 1 second. We can actually double check right away because, as I said, the NGINX Ingress controller. Let me see. NGINX. Okay. Let me take one of them. 1 second. If you can give me a second, I can check the image used by NGINX, the latest one, so we can scan it, and actually we can see how many CVs does it have. Because the problem is these CVs are not going away. They're not going to go away. They're still going to be there. They're just going to increase in number and severity, and that's the problem. So let me see. I have Ingress controller here. Let me actually share my screen once again for a couple of more minutes. Okay. And here. I install NGINX Ingress controller. Still describe code. Just move away here. Let's see. So I'm using this one. And the grep scan, I think grep scan. Oh, I'm just grepping the image actually. So I'm scanning these images against I think I updated the database recently. I think it was a week ago. So should have a good, like CV is up to date to 1 week ago. So I might not find all of them, but
a week is a long time at the moment in the security space.
Yes.
Yeah.
Actually, that's funny. You're talking about that today with another engineer, and we're like making jokes about like back in the day, like these CVs, like it was like taking months before we found new critical CVs. Now it's like every week there is something new.
Yeah. And one of the models got removed from public use only last week, the week before, I think, wasn't it? And so, like, yeah.
Yes. Yeah, I think that has something to do with that. Yeah. So let's see if this image, the 115.1, has any vulnerability based on the gripe database.
Definitely worth having a look at. For anyone,
yes.
For anyone still watching that's running NGINX right now, it's definitely worth a look.
We definitely have some critical here. So critical II, so that's pretty bad. So we have 22 critical CVs, 122 high, 7 medium, 8 low. And you can see these CVs are relatively new, like 127. Because the problem is these CVs, usually, even with Linkerd, when we find CVs, most of the time are related to dependencies, libraries used in the source code that need to be upgraded. And because the code cannot be changed, you can upgrade those dependencies. So we're still pointing to old version. And there's old version, so all is old, you're going to upgrade CVs. And you can see here, all these CVs are new, 2026.
Yeah.
2026.
Yeah.
2026, 2026, 2026. These are all new, and you can change, and that's a problem.
Yeah, cool. Thanks, Ivan. Right, well, I think that brings us to the end. Before wrapping up, I should mention that you should see in the bottom of the screen now, the next episode of Service Mesh Academy next month, July, is going to be with me. I won't be hosting it, of course, but I will be doing what Ivan's been doing today. And it's going to be based on the Trust Anchor Rotation Operator, which is a new feature that's coming to Linkerd. And it's going to be around how to make life easier when it comes to rotating that Trust Anchor certificate. So thanks everyone for watching. I don't think the link's actually showing right now, but we can distribute that as we normally do to sort of make folks aware of where they can register. Yeah, thanks everyone for watching. If there's any more questions, post them into the Linkerd Slack workshops channel, and we will get to them as soon as we can. Okay. Thanks, Ivan. Bye bye.
Thank you. Bye bye.